Hi, I'm Abzal from Confluent, and today I want to talk to you about what is arguably the best way to get data out of a transactional database and into the rest of the firm. Why would we want to do this? Well, imagine an application, any application. This could be a point of sale at Target. This could be a web application that helps you trade stocks, for example. Any application needs to persist its state in some sort of database. For our purposes today, we're going to talk about PostgreSQL, but it could be any database. What does it mean to persist your data? Well, essentially, it's just a sequence of inserts, updates, and deletes. Now, the information in this database is quite important. It's used for decision-making. So, for example, you might want to store it somewhere, provide monthly reports or other business intelligence needs like dashboards, store it in large data lakes, lake houses, data warehouses, whatever it is for long-term analytics. That data is also needed by another class of applications that actually need it in near real time. This could be back office applications like billing or further processing. They could be machine learning or LLM-based applications like RAG applications. RAG, as you know, Retrieval Augmented Generation, is about not only having access to an LLM, but also having access to live data. And again, that's where something like this is needed. And of course, there's other members of your firm where the UX department, product management, and so on and so forth want access to this data in order to help them make decisions. Now that we know why we'd like to do this, how do we go about doing it? I said arguably the best, and the word best doesn't really mean anything unless you've got criteria to back it up. I'm using 4 criteria to define the best. 1, how easy is the application to write? 2, how fresh is the data, because the fresher the better. How easy is it to deploy our application? And lastly, and this one a lot of people miss when they first create applications like this, is does it detect changes to the schema? And by that I mean if the table in Postgres inserts a new column, deletes a column or drops a column, or more dangerous, changes the format of the column. So let's take the first one. Just offhand, I'd wake up, I'd say, write a SQL client. Your programming language of choice, you write a SQL query, you run it 4 times a day, drop the records into a file, and then the rest of the firm can take it. How does it work? Well, it's pretty easy to write. SQL applications are very straightforward if you're just going to do a select star. But the data is not going to be fresh because the database isn't going to let you hit it at all times of the day. You'd have to pick some off business hours, and that would delay your data. Deployment is a problem because it's all on you. You've got to figure out how many instances of your application you're going to run, where is it going to run, how are you going to monitor it, restart them, and so on and so forth. So it's all on you. And lastly, schema changes are also something that you'd have to keep track of. You'd have to remember what they were before and what a new incoming record had. So writing our own SQL application doesn't seem very appetizing. Another sort of related way of doing things is using the database backups. So our database must have backups, weekly, daily, hourly. We could use those, restore them to another database, and then just query that with absolutely zero load on the system. Depending on how good your relationship is with your DBAs, this might be a simple application. But again, backups are late, so you're going to not have fresh data. Deployment is a challenge because now you have to figure out what databases and where do I restore them and how often and all that. And lastly, schema changes, completely up to you to detect. Modern databases have something known as a write-ahead log. This is the mechanism they use to guarantee atomicity and durability in those asset guarantees that they provide. Now that's actually a very clever notion, to read the write-ahead log and get our updates from there. You get them in near real time. The challenges, well, these are usually binary logs and you have to figure out how to read them. And of course, your code is going to have to figure out where it runs. So deployment is an issue and schema changes, again, another issue. Wouldn't it be nice if somebody wrote one for us and had a preferred way of deploying things and detected schema changes? That would be awesome. And that is what Debezium does for us. It checks all of the boxes and gives us an out-of-the-box solution for getting data out of our PostgreSQL database and into Kafka. What exactly does it do? Well, it runs on a platform called Kafka Connect. To learn more about Kafka Connect, you can take the Kafka Connect 101 course over on Confluent Developer. But essentially, it's a distributed computing platform for applications that either read from external sources and put data into Kafka, so source connectors, or sync connectors, which take data from Kafka and write them out into external places. So in our case, we are having a source connector for PostgreSQL, and we're going to get that data and put it into Kafka. Kafka is a very dominant streaming platform today, and a lot of people are familiar with it, and it makes it very easy for us to share these updates, this data coming out of the transactional database, with other teams in the firm. So what exactly does Debezium do? Well, it does something known as CDC, or change data capture. The changes that we're talking about are those commands that we talked about earlier: insert, update, delete. And what Debezium does is, for example, with the insert, it captures that and generates a message including all the values for the new record. The operation is set to a C for create, which essentially is the insert. For updates, we do the same thing, but now you can see the before record as well as the after record when an update occurs on the database. And lastly, for deletes, you can see what record was deleted. One of the things that we said Debezium handles for us is schemas. If you set the appropriate settings, then Debezium will actually embed the list of fields inside the messages themselves. Unfortunately, if we do it this way, then every downstream consumer of this data is going to have to handle the changes in the schema themselves. They'll have to detect it and figure out what they want to do with it. Debezium does connect with something known as a schema registry. This is something that Confluent provides, and there are other schema registries out there. What Debezium does is it registers the schema with this registry, and then every time a record comes in, it checks to make sure that the schema matches the existing schema. If the schema has been updated, something has been added or deleted, the schema registry has a configuration that lets it tell Debezium, this change was okay, this change is not okay, you need to stop processing and get a human being involved. So instead of all of our downstream consumers having to handle schema changes, you can do it in one central place, the schema registry. How does Debezium actually work under the covers? I think it's important to at least get a brief idea of what's going on. We've got our PostgreSQL, and we've got its write-ahead log. Debezium, running on Kafka Connect, goes ahead and makes multiple connections to Postgres and writes that data out to Kafka. Now, one of the things that Postgres uses to manage the connection that Debezium is using in order to read updates is known as a slot. The slot has a name, and essentially it's Postgres' way of making sure that it doesn't flush entries in the write-ahead log that still haven't been read by Debezium. The other bookkeeping piece that Postgres needs is which tables should it monitor for updates and send those over to Debezium, and that is known as a publication. Over on the Kafka side, you've got a system topic that keeps track of the last log sequence number that Debezium read, so that's the same thing that Postgres uses, and you can use that for custom offsets. And lastly, you do have all the actual topics being created. There is a configuration parameter to let you specify what these topics should be named, and you can set that with topic.prefix. And finally, we're talking about the Confluent Debezium CDC v2 connector, and that means that we're talking about the one that's managed and runs in Confluent Cloud. If you've got Kafka, Kafka Connect, and some sort of registry available to you, then absolutely go ahead and use that. But running it on a managed provider gives you the same benefits that any cloud managed service provides. With Confluent Cloud, you get elastic provisioning, so you don't have to over-provision and overpay for resources that you're not using, and all the lovely cloud things like infinite storage, infinite scalability, and so on and so forth. Now that we know what's going on, why don't we go ahead and look at the demo on Confluent Cloud. Here's a picture of what we're going to do. We've got Postgres running on Amazon RDS, and it's got two tables in it. The first table is append only, which means all the records are coming in and just being added to the end. And another one that's an upsert table, where if the key exists, it's updated. If the key does not exist, the record is added. On the other side, we've got Debezium running inside Confluent Cloud, and it's writing all that data to Kafka. Time to get our data out of the database and into Kafka. So we go to Confluent Cloud, log in with our credentials. For our demo, I'm actually going to create a brand new environment and go from there. So environments, add a new cloud environment. I'll call it CDC demo. I'll use just a basic cluster, putting it in AWS, and launch our cluster. Our cluster is now up and running. Next step, let's provision our Debezium connector. Going to connectors, we search for Debezium, and we pick the Postgres CDC source v2 connector. Note there is a v1, but it is deprecated. So selecting the v2 connector, there are 5 steps needed to provision and launch the connector. First step is what are the credentials we're going to use to actually write to the Kafka topic. I'm going to create a new set of keys. So my account, generate API key. I'll save it and I'll label it CDC demo keys. In case you're wondering, I am going to delete these keys later, so there's no point copying them. Okay, that was step 1. Step 2 is connecting to the database. This needs exactly the same information you would use for any SQL client to connect to the database. We have the host name, the database port, the username, the password, and we actually have a database called amashardb, and for the SSL mode, I'm going to say require. We should stay secure. One thing I'd like to point out here is that our database is behind the AWS firewalls. Since the connector actually reaches out and connects to the database, we need to make sure that that firewall allows incoming connections. If you use this dropdown, you'll find the list of static IP addresses that Debezium will use to connect to your PostgreSQL database. So you should whitelist these IP addresses in order to make sure that the connection can happen. Continue. And at this point, it does actually try and make a connection. So if you reach this third step, you actually know that you've got a connection up and going. I'm going to change my record value format. So these are the messages that are going to be written to Kafka to JSON SR. My keys will also be written in JSON format. And to make sure that I distinguish my topics that are being generated by the connector from my other topics, I'm actually going to call it CDZ amashardb. And this will become the prefix for all topics for the tables that we pull in. The rest of the items I'm going to leave as default. Slot name, publication name, no need for CSFLE, and yes, I'd like an initial snapshot. Continuing on to step 4, here we'll leave tasks.max to 1, and I'll address this in the scalability section that we'll talk about later. Here we're on our final step. You've got the connector name shown, and if we look at the piece of JSON down here, this is exactly the configuration that the Kafka Connect API needs to provision and launch your connector. Were you doing this in a production environment, you would keep this in version control so that you could refer back to the exact configuration that you've got. And having said that, let's launch our connector. Here we see that the connector is being provisioned. We'll just give it a minute until it's running. Our connector is now running, so let's have a look and see what topics it has generated for us. We have both of our topics. We have one topic from the table in which we are doing appends, so that's just got my prefix, the schema from the database, and the name of the table, sample data stock trades. And we have another topic with the upsert table, where it's actually doing upserts based on the ticker symbol. I'm going to look at some of the messages. So here, in the one in which we were doing appends only, we can have a look at one of our messages. This message here, if you notice, it says before is null, after has the record in it, some metadata, including the log sequence number, and the op is R. We haven't talked about the op R before. The R is a message that comes from the snapshot that Debezium is currently reading from the source database and pulling in all the historical records before it starts giving you live updates. And that's what the R is. If we look at one of the newer records, we'll see that we are getting new records, but these are now with a C, and that's the insert statement or create. So you did see a message from the snapshot time, and now you've got the live updates coming in. If we go back to our topics and have a look at what's going on with the upsert table, this is the one in which we actually have records where if the symbol or the ticker exists, it'll update that record. Otherwise, it'll add it, the standard upsert functionality. So let's take a look at this message here. It says, I've got before is null, after is a by, and the op is U for update. If you'll notice, even though the op is an update, I'm not getting any before values. And that's because I forgot to go and set in Postgres that the replica should have a full replication setting. if you look at some of the newer records after I have executed that SQL, you'll see that we have the previous record, so before, the updated values in after, and the op is a U. So if you're not seeing before values and you know that it's an update, then you need to go back to your table and do the replica identity set to full. And there you have it. We've got data flowing from our PostgreSQL database into our two topics. There are two features that I'd like to talk about, specifically security and scalability. Suppose you have your record coming in and it's got sensitive fields. And what you'd like to do is mask it out so that downstream consumers don't see the values of those fields. Doing that is a simple configuration inside Kafka Connect using something called simple message transforms, and there is a mask field transform that'll do this for you. The other part of security is what if you have sensitive fields that you'd like to share with only a subset of the data consumers and you want it encrypted for the rest. For that, we do also have a feature, and that's called client-side field level encryption, and that would let you securely encrypt and decrypt those values. To talk about scalability, I'd like to first talk a little bit more about how Postgres deals with Debezium connections. If you recall, the list of tables that Postgres will be monitoring for updates to send out is put together in something called a publication. A publication is associated with a slot. A slot manages incoming connections like Debezium. So if you want to think about it, one incoming connection, one slot, and one publication. Why do you need to do it this way? Because you want to be able to read those records in order, right? Getting records in the wrong order is probably not the best idea. Imagine your bank account and the debit hits before the credit. You can have multiple publications. You can also have the same table in multiple publications. And we'll talk a little bit more about that in a bit. So how does Debezium on Kafka Connect do scalability? Well, it depends on Kafka Connect to provide that scalability. Kafka Connect has one configuration parameter called tasks.max, and a task you can think of as a single thread, right? Debezium is a bit of Java code, it runs in a thread, and tasks.max defines how many threads will be running a copy of that code. As we saw earlier, given that one connection can only have one slot and therefore one publication, if we have a table, we can only use one thread to read from it. That means task.max will always be one. So what do you do if you have a large table or a table that's being updated quite frequently and that one consumer can't keep up? Well, option one is to scale up your consumer, right? Provide that particular task with more CPU, more memory, and it can handle the larger traffic. The other alternative is to partition your incoming table into multiple publications. And what you can do is either horizontally partition that table, so have a where clause, so half the records go into one publication, the other half go into the other publication, and then you have a slot for each publication and a Debezium connector for each slot. You could also vertically partition these things so you only get a subset of the columns, and you can play with those parameters until things work for your particular use case. This is for one table. Similar concepts apply for multiple tables. What you simply cannot do is have two Debezium connectors connecting to the same slot to the same table. I'd like to leave you with some of the differences between the V2 connector and the V1. The V2 connector, in addition to being faster, also supports newer versions of the PostgreSQL database. It also supports incremental snapshots. This is an awesome feature if you've got large tables. The way Debezium wakes up for the very first time is it goes and reads the entire table and puts it into Kafka. That's known as a snapshot. Now, an incremental snapshot will let you start processing the real-time new updates to the table, while in the background, so to speak, going ahead and snapshotting all the historical data. So it lets you get new data faster than if you did it the old way, where you had to snapshot the whole thing first and then start with the new records. Another feature that we've got is the ability to choose which tables Debezium will read. Previously, you had to give a list. Now you can use regular expressions to specify it. I love regular expressions. And lastly, there are configuration parameters that have been added that let you tweak the naming of your schemas as well as your topics to make life easier and more compatible with your particular application. Okay, that's it. I've shown you how it is so very easy to get data out of your transactional system and into the rest of the firm for analytics and decision making. If you're using something else, I'd be very curious to hear what you're doing, and more importantly, why. Feel free to put a comment in YouTube or reach me on the Confluent community Slack. Thanks for watching, and I'll see you on the next one.